place in our hearts and imaginations. That dream became a reality in 1969. When Neil Armstrong took his historic first steps, the potential rewards are immense. The moon is rich in resources that could fuel our future and support our expansion into space. The moon is a treasure trove. The moon is a thriving hub of human civilization. The scientific opportunities are endless, from studying the moon's geology to conducting experiments in low gravity, big and working together to turn those dreams into reality. They showed us what we could achieve with determination and innovation. The technology sphere means that temperatures can swing from extreme heat to extreme cold in a matter of hours. These challenges required innovative solutions and taught us valuable lessons about how to survive and thrive in such an environment. We gained a deeper understanding of the moon's geology and composition. The samples brought back by the Apollo astronauts have provided us with invaluable information about the moon's history and formation. These samples have helped us to understand the processes that have shaped the moon over billions of years, and have provided clues about the early history of our own planet. These lessons are more relevant than ever. As we prepare to return to the moon and establish a sustainable presence there, the knowledge gained from the Apollo missions is proving to be invaluable. It is helping us to design better spacecraft, develop more effective technologies, and plan more ambitious missions. They are the foundation upon which we build our future on the moon. The Apollo missions have provided us with a solid foundation of knowledge and experience. They have shown us what is possible and have inspired us to dream even bigger. As we look to the future, we are building on this foundation to create a new era of lunar exploration. The knowledge gained from Apollo is directly applicable to lunar mining operations. The technologies and techniques developed for the Apollo missions are being adapted and improved for use in lunar mining. This includes everything from the design of spacecraft and habitats to the development of tools and equipment for extracting resources from the lunar surface. We know more about the moon's surface. The detailed maps and images captured by the Apollo missions have provided us with a wealth of information about the moon's surface. This information is helping us to identify potential sites for future missions, and to plan more effective exploration and mining activities. We understand the challenges of operating in a vacuum. The Apollo missions taught us a great deal about the challenges of working in the vacuum of space. This knowledge is helping us to design better spacesuits and equipment for future missions, ensuring that astronauts can work safely and effectively in this harsh environment. We have developed technologies for extracting resources from extraterrestrial bodies. The lessons learned from the Apollo missions are being applied to the development of new technologies for extracting resources from the moon and other celestial bodies. This includes everything from the design of mining equipment to the development of techniques for processing and utilizing these resources. The spirit of Apollo lives on. The legacy of the Apollo missions continues to inspire and inform our efforts to explore and utilize space. The spirit of exploration, innovation, and determination that drove the Apollo missions is alive and well in the scientists, engineers, and explorers who are working to push the boundaries of what is possible. It lives on in the scientists and engineers who are developing new technologies for lunar mining. These dedicated individuals are building on the knowledge and experience gained from the Apollo missions to create new technologies and techniques for exploring and utilizing the moon's resources. Their work is helping to pave the way for a new era of lunar exploration and development. It lives on in the entrepreneurs who are investing in this exciting new frontier. The Apollo missions have inspired a new generation of entrepreneurs and investors who see the potential of space exploration and development. These visionaries are investing in new technologies and companies that are working to make space more accessible and to unlock its vast potential. And it lives on in the dreamers who look up at the moon and see a future full of possibilities. The Apollo missions have inspired countless individuals to dream big and to imagine a future where humans live and work on the moon and beyond. These dreamers are the driving force behind our continued efforts to explore and utilize space, and their vision and passion are helping to shape the future of space exploration, opening up new possibilities for exploration and discovery. Join us as we delve into the exciting possibilities and challenges of lunar mining, a venture poised to redefine humanity's place in the cosmos. From the technical hurdles to the economic implications, we will explore every aspect of this groundbreaking endeavor. The journey to the moon is just beginning, and its potential is limitless. Why is the moon suddenly generating such intense interest? This celestial body, which has been a constant companion to Earth for billions of years, is now at the forefront of scientific and commercial exploration. The answer lies in its untapped potential. The moon, often seen as a barren wasteland, is actually a treasure trove of resources and opportunities waiting to be discovered and utilized. The moon holds vast reserves of resources that are scarce on Earth, making it a tantalizing target for space agencies and private companies alike. These resources could revolutionize industries and provide new avenues for technological advancements. Helium-3, a rare isotope on Earth, is abundant on the moon. This isotope is particularly exciting because it holds immense promise for future energy production through clean and efficient fusion reactions. Fusion energy, unlike traditional nuclear power, produces minimal radioactive waste and has the potential to provide a nearly limitless supply of energy. Scientists and engineers are already working on developing the technology needed to harness this energy source. If successful, it could lead to a new era of energy production, reducing our reliance on fossil fuels and helping to combat climate change. The moon also harbors valuable metals like titanium, platinum, and rare earth elements, crucial for advanced electronics and technologies. These materials are essential for the production of everything from smartphones to electric vehicles, and their scarcity on Earth makes the moon an attractive alternative source. These resources have sparked a modern-day lunar gold rush, with nations and private enterprises vying for a piece of the celestial pie. The competition is fierce, and the potential rewards are enormous. The moon represents not just scientific advancement, but also immense economic potential. Establishing a presence on the moon could lead to the development of new industries and the creation of jobs, both on Earth and in space. It could become a hub for resource extraction, manufacturing, and even tourism in the not-so-distant future. Imagine a world where people can travel to the moon for vacation, or where products are manufactured in lunar factories and shipped back to Earth. The race is on to establish a foothold on the moon, to carve out a piece of this celestial frontier. Space agencies and private companies are investing billions of dollars in lunar missions, each hoping to be the first to unlock the moon's potential. The stakes are high, the rewards even greater. The moon holds the key to our future in space, and those who succeed in harnessing its resources will lead the way in the next great era of exploration and discovery. Section 4. Technology takes flight, making lunar mining a reality. Mining on the moon presents unique challenges, but technological advancements are paving the way for making this dream a reality. The moon's harsh environment, with its extreme temperatures, lack of atmosphere, and low gravity, poses significant obstacles. However, these challenges are being met with innovative solutions that are transforming science fiction into science fact. Robotic explorers and rovers will play a crucial role in lunar mining operations. These machines are designed to withstand the moon's harsh conditions and operate autonomously, reducing the need for human presence on the lunar surface. These autonomous machines, equipped with advanced sensors, drills, and extraction tools, will be capable of navigating the lunar surface, identifying resource-rich areas, and extracting materials with minimal human intervention. They will use sophisticated algorithms to map the lunar terrain, detect valuable minerals, and perform precise excavation tasks. 3D printing technology will be instrumental in constructing infrastructure on the moon. This technology allows for the creation of complex structures using local materials, which is crucial for establishing a sustainable presence on the moon. Imagine using lunar regolith as raw material to 3D print landing pads, habitats, and even entire mining outposts. This process not only saves on the cost and complexity of transporting materials from Earth, but also enables rapid construction of essential infrastructure. This eliminates the need to transport bulky construction materials from Earth, greatly reducing costs and logistical complexities. By leveraging in situ resources, we can build more efficiently and sustainably, paving the way for long-term lunar habitation and industrial activities. Advances in rocket technology and spacecraft design are making space travel more affordable and efficient. Innovations such as reusable rockets and modular spacecraft are revolutionizing the way we approach space missions. Reusable rockets capable of multiple trips to and from the moon will significantly lower the cost of transporting equipment, resources, and atmosphere. It would also serve as a testing ground for technologies and systems needed for future missions to Mars and beyond. The establishment of a lunar outpost would mark a pivotal moment in human history, signifying our transition from an Earth-bound species to a spacefaring civilization. It's a bold vision, one that requires international collaboration, technological innovation, and the unwavering spirit of exploration that has always defined. Among the moon's most coveted resources is helium-3, a rare isotope of helium. This isotope is incredibly rare on Earth, but is found in abundance on the lunar surface. The moon's unique environment, devoid of a protective atmosphere, has allowed solar winds to deposit helium-3 over billions of years. This non-radioactive isotope holds immense potential as a fuel source for nuclear fusion, a process that could revolutionize energy production on Earth. Unlike traditional nuclear fission, which splits heavy atoms to release energy, nuclear fusion combines light atoms, such as those of helium-3, to produce energy. This process mimics the reactions that power our sun and other stars. The potential of nuclear fusion is staggering. It promises to provide a nearly limitless supply of energy, which could power our cities, industries, and homes with unparalleled efficiency. Imagine a world where energy is abundant, clean, and sustainable, reducing our reliance on fossil fuels and mitigating the impacts of climate change. Fusion reactions involving helium-3 release vast amounts of energy, far exceeding that of traditional nuclear fission. The energy released from just a small amount of helium-3 could power entire cities for extended periods. This makes it an incredibly attractive option for future energy needs. Moreover, unlike fission, fusion produces no long-lived radioactive waste, making it a cleaner and more sustainable energy source. The byproducts of fusion are generally harmless, and the process itself is much safer, with no risk of a catastrophic meltdown. This positions helium-3 as a key player in the quest for sustainable energy solutions. The moon's surface is thought to contain significant deposits of helium-3 deposited by solar winds over billions of years. These deposits are spread across the lunar regolith, the layer of loose, fragmented material covering solid rock. Mining helium-3 from the moon would require advanced technology and international cooperation, but the potential rewards are immense. Extracting and utilizing this resource could provide a clean and nearly limitless energy source for future generations. The development of lunar mining operations and the establishment of a helium-3 supply chain could transform our energy landscape, ushering in a new era of prosperity and environmental stewardship. The moon, once a symbol of mystery and exploration, could become the cornerstone of our sustainable future. Another vital resource found on the moon is water ice, trapped in permanently shadowed craters at the lunar poles. This discovery has profound implications for space exploration, as water can be broken down into hydrogen and oxygen, providing breathable air and rocket. Section 5. Challenges in the lunar landscape. Despite the promise of lunar mining, numerous challenges and risks must be addressed. The moon's harsh environment, with its extreme temperatures, radiation, and lack of atmosphere, poses significant engineering and logistical hurdles. Developing mining equipment capable of operating reliably in these conditions is a significant challenge. Transportation costs to and from the moon remain prohibitively high, and the ethical implications of lunar mining require careful consideration. Section 6. The ethics of extraterrestrial mining. As we venture into this new era of resource extraction, ethical considerations must be paramount. The moon, Mars, and other celestial bodies hold vast amounts of untapped resources, from rare minerals to water ice, which could be crucial for future space missions, and even for life on Earth. The Outer Space Treaty of 1967 prohibits national appropriation of celestial bodies, stating that space is the province of all humankind. This treaty was a monumental step in ensuring that space remains a realm of peace and cooperation. However, the treaty's provisions regarding resource extraction remain ambiguous. While it prevents any one nation from claiming sovereignty over the moon or other celestial bodies, it does not clearly address the rights and responsibilities of private entities or international consortia in mining these resources. Some argue that the moon's resources belong to all humankind and should be managed for the benefit of all. This perspective emphasizes the need for a collective approach, ensuring that the benefits of space mining are shared equitably and that the environmental integrity of these celestial bodies is preserved. Others believe that private companies and nations should be free to exploit these resources for profit. They argue that the innovation and investment driven by the private sector are essential for advancing space exploration, and that economic incentives will accelerate technological development. Establishing clear guidelines and international cooperation is crucial to prevent a free-for-all that could damage the lunar environment and lead to conflict. Without a robust legal framework, the race for extraterrestrial resources could result in environmental degradation, geopolitical tensions, and even armed conflict. Therefore, it is imperative that the international community comes together to create comprehensive regulations that balance the interests of all stakeholders, protect the space environment, and ensure that the benefits of space mining are distributed fairly. Section 7. A new space race? The potential for conflict over lunar resources is a serious concern. As demand for these resources grows, so too might the temptation for nations and corporations to secure their share, potentially leading to a new space race. Such a race could undermine international cooperation and lead to tensions on Earth. It is essential to establish a framework for equitable resource sharing and conflict resolution to prevent lunar mining from becoming a source of geopolitical instability. Section 8. Weighing the cosmic scales. The prospect of lunar mining presents both incredible opportunities and significant challenges. On the one hand, it offers the potential to address some of humanity's most pressing needs, from clean energy to resource scarcity. On the other hand, it raises ethical concerns about environmental protection, resource allocation, and the potential for conflict. Carefully weighing these factors is crucial to ensuring that lunar mining benefits all humankind and does not come at the expense of our shared celestial heritage. Section 9. Conclusion. A giant leap for mankind? As we stand on the cusp of this new frontier, the choices we make today will determine the future of lunar mining and its impact on humanity. It is a journey fraught with challenges, but also one filled with immense promise. By proceeding with caution, international cooperation, and a deep sense of responsibility, we can ensure that lunar mining becomes a force for good, propelling us. Humanity has always looked to the stars. From the earliest civilizations, we have been fascinated by the celestial bodies that adorn our night sky. The stars have inspired myths, guided explorers, and sparked the imaginations of countless generations. They represent the unknown, the final frontier, and the ultimate challenge for human ingenuity and curiosity. The moon, our celestial neighbor, has beckoned us for centuries. Its silvery glow has been a constant presence in our lives, influencing tides, calendars, and even our dreams. The moon has been a symbol of mystery and romance, a muse for poets and artists, and a target for scientific inquiry. It is the closest celestial body to Earth, making it the most accessible destination for space exploration. Now, a new era of space exploration is dawning. With advancements in technology and a renewed sense of purpose, humanity is poised to return to the moon. This time, our goals are more ambitious than ever before. We are not just aiming to plant flags and leave footprints. We are planning to establish a sustainable presence on the lunar surface. This marks the beginning of a new chapter in our quest to explore the cosmos. We are returning to the moon, not just to visit, but to stay. The vision of a permanent lunar base is becoming a reality. Astronauts will live and work on the moon, conducting scientific research, testing new technologies, and preparing for future missions to Mars and beyond. This endeavor requires international collaboration, innovative engineering, and a commitment to pushing the boundaries of what is possible. This time, our mission is driven by a new ambition: to mine the moon's resources. The lunar surface is rich in valuable materials such as helium-3, rare earth elements, and water ice. These resources have the potential to revolutionize industries on Earth and support long-term space missions. Mining the moon could provide the raw materials needed for building infrastructure in space, fueling spacecraft, and generating clean energy. The moon holds the key to unlocking vast potential for our future on Earth and in space. By harnessing its resources, we can reduce our dependence on Earth's limited supplies and create a more sustainable future. The moon's proximity to Earth makes it an ideal location for testing new technologies and developing the skills needed for deep space exploration. It is a stepping stone to the stars, offering a glimpse of what is possible when we dare to dream big. Imagine a future fueled by clean energy from the moon. Solar panels on the lunar surface could capture the sun's energy and convert it into electricity, providing a reliable and sustainable power source for lunar bases and even for Earth. The concept of a lunar power station is no longer a distant dream, but a tangible goal that scientists and engineers are working towards. This could revolutionize the way we think about energy and open up new possibilities for space exploration. Imagine building infrastructure in space with materials mined from the lunar surface. 3D printing technology could be used to construct habitats, tools, and equipment directly on the moon, reducing the need to transport materials from Earth. This would make space missions more cost-effective and sustainable, paving the way for long-term human presence on the moon and beyond. The possibilities are endless, and the potential for innovation is immense. This is not science fiction. The advancements in space technology and the growing interest in lunar exploration are making these visions a reality. Governments, private companies, and international organizations are investing in lunar missions, developing new technologies, and collaborating on ambitious projects. The dream of living and working on the moon is closer than ever before, and the benefits for humanity are profound. This is the future of space exploration, and it's closer than you think. The next decade will see significant milestones in lunar exploration, from the establishment of lunar bases to the development of new technologies for mining and construction. These achievements will lay the groundwork for future missions to Mars and beyond, expanding our horizons and pushing the boundaries of human potential. The moon is our stepping stone to the cosmos, and its resources will pave the way for a new era of human progress. By embracing the challenges and opportunities of lunar exploration, we are taking the first steps towards a future where humanity is a multi-planetary species. The journey to the stars begins with the moon, and the possibilities are as vast as the universe itself. The moon holds a treasure trove of resources. For centuries, humanity has gazed up at the moon, dreaming of what secrets it might hold. Now, as we stand on the brink of a new era of space exploration, we are beginning to unlock those secrets. The moon is not just a barren rock in the sky, it is a potential goldmine of resources that could transform our future. One of the most promising of these resources is helium-3. This rare isotope has captured the imagination of scientists and engineers alike. Unlike anything we have on Earth, helium-3 offers a glimpse into a future where energy is abundant and clean. Helium-3 is a rare isotope on Earth, but abundant on the moon. This abundance is due to the solar winds that have bombarded the lunar surface for billions of years, embedding helium-3 into the regolith. Extracting it from the moon could provide us with a nearly limitless supply of this valuable resource. Why is helium-3 so important? The answer lies in its potential to revolutionize energy production. Traditional nuclear power relies on fission, which splits heavy atoms and produces long-lived radioactive waste. Helium-3, on the other hand, can be used in fusion reactions which combine light atoms to release energy, because it has the potential to revolutionize energy production. Fusion reactors powered by helium-3 could provide a nearly endless supply of clean energy. This would be a monumental leap forward, reducing our dependence on fossil fuels and cutting down on greenhouse gas emissions. Helium-3 could fuel clean, safe fusion reactors. These reactors would not produce the long-lived radioactive waste that is a byproduct of current nuclear fission reactors. This means a safer, cleaner future for our planet. Unlike nuclear fission, fusion doesn't produce long-lived radioactive waste. This makes it an incredibly attractive option for sustainable energy. Imagine a world where our energy needs are met without the environmental cost we currently pay. It's a game changer for our energy needs. Cities of the future could be powered by helium-3, leading to cleaner air, reduced carbon footprints, and a more sustainable way of life. The implications are vast and could touch every aspect of our daily lives. But helium-3 is just the beginning. The moon holds more than just this one resource. As we continue to explore and understand our nearest celestial neighbor, we are discovering a wealth of other materials that could be just as transformative. The moon is also rich in rare earth elements, vital for our technology. These elements are essential for the production of modern electronics, renewable energy technologies, and even advanced medical devices. These elements are used in everything from smartphones to electric cars. Our modern world relies heavily on these materials, and the demand for them is only increasing. Mining them on the moon could provide a new sustainable source. Mining these resources on the moon could reduce our reliance on Earth's limited reserves. This would not only help preserve our planet's environment, but also ensure a steady supply of these critical materials for future generations. The moon, once a symbol of mystery and wonder, is now becoming a beacon of hope and possibility for a sustainable future. Mining the moon won't be easy. The lunar environment is harsh and unforgiving. Temperatures swing wildly between extreme heat and cold. There's no atmosphere to protect us from radiation or micrometeoroids. The lack of gravity also poses a challenge for both humans and equipment. Dust is another major issue. Lunar dust is fine and abrasive, and it can damage equipment and pose health risks to astronauts. Overcoming these challenges will require innovative engineering and a spirit of human ingenuity. Thankfully, technology is advancing rapidly. Robotics and automation will play a key role in lunar mining. We're developing autonomous rovers and mining robots that can operate in the moon's challenging environment. 3D printing will allow us to build structures and even tools using lunar regolith, the loose material on the moon's surface. Private companies are leading the charge. SpaceX, Blue Origin, and others are developing the rockets and spacecraft needed to get to the moon and back. New companies are emerging with a focus on lunar mining, developing innovative technologies and partnerships to make this vision a reality. Section 5. A new economic frontier impacts on Earth and space. Lunar mining has the potential to revolutionize our economy both on Earth and in space. The resources we mine on the moon could fuel a new era of economic growth. Imagine using lunar resources to build solar power stations in space, beaming clean energy back to Earth. The moon could also become a hub for manufacturing and resource processing. Mining and utilizing resources in space reduces the need to transport them from Earth, saving on cost and energy. This opens up new possibilities for space exploration and development. Section 6. Ethical considerations. Owning the moon? Lunar mining also raises important ethical and legal questions. Who owns the resources of the moon? The 1967 Outer Space Treaty states that no nation can claim sovereignty over the moon, but the treaty is silent on the issue of resource extraction. As we venture into this new frontier, we need to establish clear guidelines and regulations. We need to ensure that lunar mining is conducted in a responsible and sustainable way that benefits all of humanity. Section 7. International cooperation, a shared lunar future. The moon belongs to all of us. International cooperation will be essential for the success of lunar mining. By working together, we can share the costs and risks of this endeavor. We can also ensure that the benefits of lunar mining are shared equitably among all nations. Imagine a future where nations collaborate on ambitious lunar projects. Picture a diverse international team of astronauts and engineers working side by side on the lunar surface. This is the future we should strive for. Support both lunar and Earth-based needs. A steady stream of spacecraft travels between Earth and the moon, transporting people, equipment, and resources. These journeys today. Section 9. Conclusion: a giant leap for humankind. Mining the moon is not just about extracting resources, it's about pushing the boundaries of human ingenuity and expanding our presence in the solar system. It's about creating a future where space is accessible to all, and where the resources of our celestial neighbor help us build a better future for humanity. This is our next giant leap. Let's make